Hello, welcome to Analog Output. Been off the air a while. I thought I'd show you a little of what's been progressing since then. This is kind of the state of Kosmodrome, the synthesizer. It's still got some big gaps to be filled, not going as fast as I had originally thought. That's my own fault, but we're making progress. So what's happening with this synthesizer? Well, it's got a back on it. Got some wood back here. For a long time, didn't have a back on this thing. Finally decided to put one on. Also, you can see there's a power supply up there and another power supply down there. So there's two of them now. And as for the modules, some of these you've seen on videos, like this one, the low frequency oscillator. Up here we got an envelope generator. This is new. I'll be talking about that more in another video. Here's the noise source and the voltage controlled oscillator. You've seen that. The gap here, this is the envelope generator is going to go in here, and there's going to be another envelope generator next to it, which I think is probably going to be the same design again, but haven't decided for sure. The gap next to the VCO, that's going to be another VCO, and I think that's not going to be the same design. I'm working on a design of my own. That's going to take a while, but it'll be there. Then we've got the attenuators. We've got an audio mixer. This is a new module. Not much to say about it. Very simple circuit, went together easily. This is a voltage controlled filter, a Sallen key filter from Barton Musical Circuits, and that one's got a story. This is actually one of the first modules I built for Kosmodrome, but I didn't make a video about it because it seemed to be working kind of funny. It was doing something, but it was kind of weird, and eventually I decided, yeah, this really is not working right, and I need to fix it, and finally got around to, several weeks ago, taking a look at it, and couldn't find anything wrong with it. I tried breadboarding the same circuit and poking at it with that, still couldn't make any progress. Finally just emailed Michael Barton and asked him if he had any ideas, and he had some suggestions, one of which turned out to be absolutely right. There was a point that I'd forgotten to connect to ground, and that was screwing things up. So this thing is now working properly, which is nice. But in the meantime, partly because I wasn't sure if this thing would ever work properly, and partly because even working properly, it's got some sound characteristics that are not necessarily what I would always want to have in a filter. I decided I wanted to have a different filter so I could have a choice of what kind of sounds to get. And so I am now working on another filter, a transistor ladder filter that's going to go right over there. You'll be seeing that pretty soon. Down in the next row, we've got the MCVI MIDI to CV. We've got a great big gap here, which is going to be filled with a couple of modules, one of which is going to be a great big 20 centimeter by 20 centimeter monstrosity, which I hope to have done in the not too distant future. Looking forward to see how that works out. And we got the multiples, we got dual voltage controlled amplifier, got the DC mixer. This gap here, not sure what's going to go into it. Actually, what's going to go into it at some point when I get around to it is I've got up here a stack of blanks. So that's going to go in there just to fill that hole. And finally, we got the stereo output. This is another one with a story. This is a module that's been sort of in progress for about the past year, or lack of progress or something. Lots of things went south with this module, partly because of some really boneheaded mechanical design decisions that I made. And it was a real pain in the butt putting it together, getting it working, troubleshooting it, taking it apart, putting it together again. If I hadn't been able to get this thing in this incarnation working, I wouldn't have tried to build another of the same design. I would have just gone back to the drawing board and started over with the design. The circuit design was fine, but just the way the whole thing was designed to be put together was just not good. But I did finally manage to get everything working and shoved everything together. It's a mess behind the panel, but it works and looks okay from the front, I guess. So that's where things are, and you'll be seeing progress on that filter pretty soon. You'll be seeing a video about this thing pretty soon, and then hopefully these two modules here in the not too distant future. So the only other thing I wanted to say was I wanted to talk about these panels. These are fabricated in the same factory that does the circuit boards behind the front panels. And that's something you can probably see lots of videos on YouTube about. So I'm not going to go into great details about that, but I just want to tell you a little bit about some recent developments on that subject. So let's take a look at that. So we got a circuit board here. This is the good side. This is something I laid out myself using a software package called KiCad. You get into the software and you drag the footprints into place and you connect up the connections between them, and you export that all to a Gerber file set, which you then upload to a fabrication facility, and you send them some money and they make the circuit boards and send them to you, and there you go. What you've got here, you've got an FR4 substrate. FR4 is an epoxy fiberglass laminate. It's what's usually used for circuit boards, and then on top of the FR4 on both sides there's a layer of copper which is etched away in order to make the circuit connections. And then on top of the copper there's a layer of solder mask, which is this black stuff on both sides. And on top of the solder mask there's the silkscreen layer, which in this case is white, and it's got the labels for the components and the fancy analog output logo and information about the board and all that. And there's holes. There's a lot of holes here, which have solder pads for mounting components and connecting them to one another. And that's your circuit board. This is front panel, and it's made in exactly the same way. I've already done a video a while back about making your own front panels out of aluminum with paper and transparent vinyl covering on the front. I do that sometimes. All the ones you saw in the Kosmodrome synthesizer, though, are fabricated like this one. And this is done in exactly the same way. It's done in the KiCad software package. You drag in the footprints that correspond to these holes here, and put in the artwork that's going to go on the silkscreen layer. But again, it's FR4 copper on both sides, which is in this case not really etched away much because there's not much of anything in the way of circuitry. It's just a solid copper on both sides, which helps with electromagnetic shielding. And then you've got the solder mask, which in this case is white, and you've got the silk screen, which in this case is black, and is just some graphics that I drew up in Inkscape and brought into KiCad, exported to a Gerber file, uploaded, and the same place that made these. But just wanted to mention something happening recently is the fabrication company I use has started offering a different substrate, which is aluminum. And why would you want to make a circuit board on aluminum? Well, heat dissipation. My understanding is that this is mainly for things like if you're designing an LED light fixture, and the LEDs put out lots of heat. You want to dissipate that heat. Aluminum circuit boards are better for that than FR4. But you can also make front panels with aluminum, and that's what we have here. Now the thing with the aluminum is you can't have through hole components like this, because then they would be there's an insulating layer on both sides to keep the components away from the aluminum, which would then connect them together and ruin the circuit. But if you had through hole components like these as opposed to surface mount ones, then they would all be connected together through the holes. It wouldn't work. So you can't have through hole, and you could in principle have components on both sides of aluminum, but that would cost a lot more. There are some companies that offer that, and it's staggeringly high prices for two-sided aluminum circuit boards. But for single-sided aluminum circuit board, the company I use, they charge the same amount for this as they do for two-sided FR4. And for front panels, single-sided is plenty. There isn't a circuit there, so you don't worry too much about whether you can put components on both sides, right? So this is single-sided aluminum substrate, and other than that, it's pretty much as before. You've got your substrate here, you've got a copper layer, you've got a solder mask layer, you've got a silkscreen layer, you've got holes which have pads around them, which you're not using for soldering, but you're using them to contact the metal parts of the components you're putting in here and connect them to ground and connect the ground to everything else. But it's single-sided, so on the back you can see that whereas here you had solder mask on the back, here I think you can tell you've got what looks like bare aluminum, although there's actually, as I said, an insulating layer on top of the bare aluminum. And so you don't get a copper layer back here, you don't get a solder mask layer back here. You do get a silkscreen layer here, which you can see that's got my name and date and stuff like that there. So aluminum front panels. Initially I thought this would be really nice because I would expect the aluminum front panels to be stiffer than the FR4 ones, and when you're plugging and unplugging the jacks, there's a certain amount of flex in these things. Turns out, though, that the flex for both of these is not that much different. I haven't done a really careful scientific study with loading with a known force and so forth and so on, but just in my hands, if I try to flex the FR4, and if I try to flex the aluminum, it's not that much difference. Maybe a little bit stiffer here, not that much different. What other advantages might there be for aluminum? Well, it's something pretty subtle, and I'm sure you can't see it on the camera. It's hard enough to see it in person, but the surface on the FR4 is a little bit less smooth than the surface on the aluminum. This is, like I said, this is an epoxy fiberglass laminate. It tends to have some sort of fibrous structure to the surface. It's a little smoother on the aluminum, but you have to get up really close to see it. So is there really an advantage? I don't know. On the other hand, as I said, both of these cost the same amount. this one's a little bit nicer, so why not? When you go to do this, they say, if you ask them, they say, yeah, you should submit, just a Gerber file that doesn't have the back layers and doesn't have plated through holes. And I've been doing that. Initially, I thought I had to kind of change my process in KiCad to make that work. But eventually I figured out you can just use the same files that you would use for this. It's just you delete the files having to do with the back layer. And I've been going in and changing where it says plated through holes, where it says PTH, I've been changing it to NPTH for non-plated through holes, and that works fine. And I've been told by other people that they've just submitted the same thing with the back layers, with the plated through holes, and they just go ahead and make it without the back layers and with the holes not plated through. But I figure it makes a little sense to actually delete the back layers and change the plated through holes to non-plated, just to make it absolutely clear what I really have in mind. A little less confusion that way. The one detail is, if you want to make an electrical connection to this aluminum in order to have this aluminum plate be grounded as opposed to floating, which is probably a good idea. As I said, there's an insulating layer here. It looks like bare aluminum. It's not bare aluminum. If you take a multimeter and stick it on here, it doesn't conduct. If you take a multimeter and stick it inside these holes, they do conduct. So if you've got, a jack in this hole and it's connected to ground, then maybe this aluminum's connected to ground. On the other hand, it's not a very good solid mechanical connection between the inside of the hole and the jack if the hole's kind of large enough that fit is a little bit loose. So what I've been doing is I've just been taking a little sandpaper and sanding off the area around one of the jacks so that it makes a good electrical contact there. And then if the jack is grounded, the aluminum is grounded, everything's grounded, everything's happy. So that's been my panel process lately, and it's worked out for me. Give it a try. Anyway, that's what we have for now on analog output. As I mentioned, we'll be talking soon about an envelope generator. We'll be talking soon, I hope, about a transistor ladder filter, and maybe we'll take a look at the transistor matching process. And beyond that, got some other fun stuff coming up. So, like it if you liked it, subscribe if you liked it, and see you next time on Analog Output.